Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Muhammad Marifat bin Muhammad Sabri and my metric number is 144768. Today, I am the first representative from Group 12 regarding the assignment of EBB 337, which entitled Carbon-Carbon Composite. In front you can see the name of the representative or the participants in our group. First one we have Anis bin Shamsuddin 143923, Muhammad Taufiq bin Muhammad Jauhar 143770, myself Muhammad Iman Rifat bin Muhammad Sabri 144768, and lastly Riyasami Kartigan son of Selbam 144440. Without further ado, let's go to the first slide. Okay, first of all, in my part, the introduction, what is a composite? So, when two or more different materials are joined in order to create a much superior or unique type of material, it is called as a composite. So, in composite, there is known to be matrix and fiber, which we know as the composite filler, the composite faces, matrix or binder as the continual face, and also the reinforcement of filler, which act as the disperse face, and also the interface, which known as a point of contact between the matrix and also the reinforcement. Next, we have the properties composites. As you can see here, there are a lot of properties that can be known and attributed to the composite itself. It has high strength to weight ratio, lightweight, fire resistance, electrical properties, chemical and weathering resistance, colorful design flexibility, low thermal conductivity, and also the economical of manufacture. Now we move to the most crucial part itself, carbon-carbon composite, or also you can know as the carbon-carbon composite CCC. So it is known as the following. It is known as the reinforced composite, carbon fiber reinforced composite CFRCC, and then carbon matrix. Also is a composite with an amorphous carbon because it contains the carbon structure itself, and then the graphitic carbon fibers will enhance the carbon matrix. Plus, this CCC, carbon-carbon composite, is invented in 1958, but it is not to be fully invented until the implemented of the space shuttle program. Plus, carbon-carbon composite, this is the description, the whole CCC. So, CCC are the composites which are the reinforcing fibers and the matrix material, both made of pure carbon. And for CCC, on the other hand, are known as a woven mesh of carbon fibers because they both contain only pure carbon, and they are used because of their high strength and rigidity modulus. And plus, composites are also a lightweight material which can withstand much higher temperature as high as 3000 degrees Celsius, and as a result, the structure of carbon-carbon composites can be really modified in order to fulfill the targeted and specific needs of application.
Okay, here I will explain about properties of carbon-carbon composite. Carbon-carbon composite, also we call as CCC, has many properties, which is thermal shock resistant over 200 degree, low thermal expansion coefficient, elasticity with a high modulus, high thermal conductivity, low density, high intensity, low friction coefficient, high abrasion resistance, also thermal resistant in a non-oxidizing environment, and then high in electrical conductivity. Okay, next we look at the graph of strength of materials. Here we can see there is a lot of materials which are carbon composite, aluminium, the green one, titanium, blue one, inconel, purple nodular iron, the orange. So we can see if higher the temperature, the strength of materials will decrease. We can see for the carbon composite, the strength of materials is remain the same. So which is this composite retain their physical properties even at the higher temperature compared to the other materials that their strength become decrease when the higher is increased. Okay, we look at the graph of specific tensile strength. Here we can see the materials that we can see carbon composite have higher specific tensile strength compared to the other materials. Uh, we can see carbon composite offer outstanding tensile strength uh, compared to other material for its density. We go through the processing of carbon fiber. Carbon fiber is produced by pen process. The polyacrylonitrile method produces about 90% of the carbon fibers manufactured. The remaining 10% is made out of rayon or petroleum pitch. Carbon fibers are manufactured using this process by converting a pen precursor through the following stages. First, stretching polyacrylonitrile precursor filaments and heat oxidation at 200 degrees Celsius. And then tension is maintained between the filaments. For the several hours, carbonization took place in a nitrogen environment at a temperature around of 1200 degrees Celsius. Non-carbon elements such as oxygen, nitrogen, and hydrogen will volatilize at this step, resulting in carbon enrichment of the fibers. Graphitization at a temperature of around 2500 degrees Celsius.
Okay, based on the figure, you can see the how carbon fiber is processed. Well, you can see the major components that are working, but I would like to say that I can conclude it by uh, five major components by spinning. First, you have to spin it with the pan, which is mixed with the other ingredients, spun into fibers, which they are washed, stretched over there. So during the stabilization, the fibers undergo chemical alteration to stabilize and they are bonding. Okay, the next one is you see from the slide is carbonizing. So from there you can see the stabilized fiber uh, will be heated at a very high temperature, firmly tightly bonded so that the carbons are bonded very tightly between the crystals. Uh, the next one is treating the surface. The surface of the fibers is oxidized to improve the bonding properties. So when you're about to seize, when you're about to do the sizing of the sample, the fibers are coated and wound into the mm, onto the bobbins, which are loaded, and the spinning machine, it will twist the fibers, and when twisted, the different size of the yarns is formed. So the fibers that are produced into the composite used in pressure and it is vacuum that so that it bind together with the plastic polymer. So that's how it works for the carbon fiber. So the next one is fabrication of carbon composite. So there are two fabrication there. You can see it's a liquid phase infiltration and chemical vapor deposition. So based on the liquid phase infiltration, the main process that we use is pyrolysis. So it's a chemical deposition where there's absence of oxygen. So that's pyrolysis, where you under the high pressure and high temperature for the desired density, the pyrolysis cycle is will go through around like 3 to 10 minutes. So during the high pressure and high temperature at that time, the density that is formed would be the required density that we wanted to form. So when the heat is transformed from the amorphous carbon into the crystalline carbon, the range of the temperature is between like 1500 to 3000. So the modulus of elasticity are both increased at the heat treatment of in the liquid phase infiltration. Okay, for next one is chemical vapor deposition. In this deposition, from the infiltration that from the hydrogen gas at the temperature of 920, we can see the deposition of the fiber that causes to be pyrolyzed. In the process, we can see the length of the process is determined by the thickness of the fiber of the preform. From the thickness, we can know how long we have to put in the vapor deposition. So the use of the heat enhance the elasticity and strength modulus. This method will increase the tensile strength and elasticity modulus. Thank you.
I'm going to explain about the flowchart of manufacturing process. So the manufacturing process that I'm going to explain is the carbon fiber structure formation. So for this manufacturing process, we have two methods, which is a liquid impregnation, thermosetting resin pitch, and also the chemical vapor deposition hydrocarbon gas. So first, I'm going to explain about the liquid impregnation thermosetting resin pitch. For this process, we will go for the carbonization process from 500 to 1000 Celsius. This is my mistake, it's supposed to be 1000. Okay, then this process will be repeated about 5 times, and after that we will go for the heat treatment process from 2000 to 2800 Celsius. After that we will get our product, which is a carbon composite. Next, during the chemical vapor deposition hydrocarbon gas, we will go for this process for 1000 to 1200 Celsius, and we will repeat this process for 1 to 3 times, and after that we will go for the heat treatment from 2000 to 2800 Celsius. After that we will get our carbon composite. Next, I'm going to explain about the limitation of CVD. Okay, the limitation of CVDs are the gases containing hydrocarbons infiltrating the interfilament surface and cracks. These gases can sometimes accumulate on the outer cracks and resulting in a large number of pores in our materials. The densification and reinfiltration are required to overcome this problem. So a month-long procedure for specific application is required to overcome these problems. So next, I'm going to explain about the application of CCC. CCC is also known as a CC composite, and this is the materials that we use for the higher usage of application. For example, the application of CCC is refractory materials, hot press die, high performance braking system, which is known as a brake pads, the component of a turbojet engine, the element of heads, node tips for missiles, throat with the rocket motors, cutting edges, for example the space shuttle, the shield against heat, the target for x-rays, the brakes for airplane, the vehicle for re-entry, the implantable biomedical devices, the piston in engines, heat sinks, which is made of the electronic component, the bodywork for cars and motorcycles. So this is a picture of the application of CCC composite. This is a jet engine and this is the turbulence. So there are many advantages for the CCC, which is a carbon composite. The advantage of CCC is it is lightweight, which is only about 1.6 to 2.0 G over cm cube. So in non-oxidization environment, it has a high strength at a high temperature, which is up to 2000 Celsius, which is quite high actually, and also have a thermal expansion coefficient which is quite low. This is good for the material's mechanical structure. And next, it has a higher thermal conductivity when compared to copper and silver. So the CCC composite also has a thermal shock resistance which is quite high and which is good for the heavy application, for example for the engine body, for the brake pad, and etc. Even have advantages in the same time, and also have disadvantages. So for CCC, the disadvantages is the fabrication cost is too high because we're doing a heavy duty material, right? So there's a higher cost that required to fabricate the materials, and also have a porosity second. And the second has a poor oxidation resistance, which is the gaseous oxides production in an oxygen atmosphere. And next is interlaminar characterization is quite poor for this material. So this is the all the disadvantages of CCC, which is known as a carbon composite. Okay, so that's all from our group presentation, and hope that all our message can be understood by people watching this video. Thank you so much and have a nice day. That's all from us.